Hi everyone, my name is Caitlin Stewart and today I'll be talking about experiment number 4 titled What's in the Water. This is just a little brief outline to help my audience follow what I will be talking about throughout my presentation. Today the purpose of this experiment was to identify the compounds found in the drinking water sample, and to do this we use the NMR and IR spectrums. So later in my presentation I will be sharing what those two things are. And then I focused on the compound ethyl formate because that is the compound that I studied the NMR and IR spectrums. And then I will just be talking a little bit about the significance, why ethyl formate should not be in our drinking water, and why it's important that we know what can be in our drinking water. So what is an NMR? Before I completed this experiment, I was unaware of what an NMR and IR spectrum are myself, so I think it's important to identify these things. According to Gregory Burst, an NMR, which stands for nuclear magnetic resonance, shows how many different types of hydrogen atoms are present and the relative number of these hydrogen atoms. This is done when a sample is placed in a magnetic field while radio waves are placed through it. These radio waves cause the nucleus of the molecules to react and create frequencies, and these frequencies cause the different peaks of the NMR spectrum. So right here is the NMR of ethyl formate. As you can see by looking at the structure, you can predict the NMR. So this has 3 different groups of hydrogens, and within each group there's a different number of atoms. And by looking at the number of atoms in each group, you can determine the height of the peak. So there is 3 groups of hydrogen, so you will see 3 peaks, and then the height of the peaks determines how many atoms were in each group. So it is also important to identify what an IR spectrum is. And according to Ari Luxon from the article How Does IR Spectroscopy Work? Infrared spectroscopy shows the identity of the different functional groups in the compound. So there's many different functional groups, and each functional group has a predetermined wavelength. And these different wavelengths determine the height of the peak that you see in the IR spectroscopy. So how is this done? This is determined by a liquid sample being placed between salt plates to allow the infrared light to shine through it. When the light hits a molecule, the bonds of the molecule absorb energy and vibrate. So this is the IR spectrum of ethyl formate. If you looked at the structure of ethyl formate, the different functional groups, which are like bonds between atoms, have different predetermined wavelengths, and these wavelengths portray the different peaks that you see on the spectrum. So why do we care? I know that all probably sound like gibberish, a lot of scientific long words, but it is important to know what is in our drinking water and the consequences of being exposed to ethyl formate. So according to the National Library of Medicine HSDB database, exposure to ethyl formate can result in irritation of eyes, nose, and throat, and if exposed to this compound for too long, it causes headaches, nausea, and vomiting. So that's how it can affect us, but it also affects our environment and the creatures that we share it with. So if it is if it remains long in the soil and groundwater, it can negatively affect the underwater organisms. So it's really hard to get rid of, and it remains long in the soil, in the water, and this negatively affects the creatures that we share Earth with. And those are just my references. So overall, I think it's very important to know what we are putting in our bodies and what are we doing with compounds and how we dispose them and where we put them, because it affects our environment and it affects the creatures we share it with. Thank you.